Right. Our first topic will be differentiation. Right. Remember in our last topic we were drawing caves. We drawn a cave like that one that I have drawn the first diagram there. Um, we called it a parabola or just a cave. Right. Then there was a time when we were asked to find the gradient at a certain point. Like to say, find the gradient when x is equal to 2, say 2. Then you had to draw a tangent like this. And then you find the gradient of that tangent. Then that will be the gradient of the curve at the point x is equal to 2. Then there is a quicker way. You can use differentiation to find the gradient function. It's now called the gradient function. That you can put the values of x into that gradient function, and then automatically you find the gradient at that respective point, right? We'll start by this equation or this function, y is equal to x squared. And if y is equal to x squared, find dy by dx. That gradient function is called dy by dx, right? So generally, if y is equal to x to the power n, and then it means that dy by dx is n x to the power n minus 1. It means it simply means you are subtracting. Sorry, you are dropping the power first. You are dropping the power n to this side, and it becomes a coefficient. Then you subtract 1 from the same power. And that if we come here and say we have a function y is equal to x squared, then we drop the power, which is 2, then it becomes a coefficient like this. Then we subtract 1 from the power, then it becomes x to the power 1. So our dy by dx is 2x if y is equal to x squared. Then there are different names for this derivative. It can be called a derivative. It can be called a derived function, or a gradient function, like I said before, or just dy by dx. Right. So that's differentiating. So it means that this dy by dx, and we said we want to find the gradient of the curve when x is equal to 2. Then you can just put x here, which is 2. Then you find 4, which means 4 will be the gradient at this point of the curve. Then I've put in some examples here. Find the derivatives of the following functions. Y is equal to x to the power 5, y is equal to 2x to the power 3, y is equal to 2x cubed plus 3x to the power 5, and y is equal to x squared plus 2x plus 7. And here are the solutions. Number 1, we have x to the power 5. Right, it means we are dropping the power, which is 5, and it becomes a coefficient here, and you subtract 1 from the power, which becomes 4. Then number 2 is the same thing. If you drop the power, it's going to multiply with 2, and it becomes 6, and then it becomes 6x squared. We have subtracted 1 from 3, and it becomes 2. That's the value of dy dx, or the derived function. Then number 3, y is equal to 2x cubed plus 3x to the power 5. Right. This is the sum. You differentiate each and every term on its own. We are differentiating 2x to the power 3, which means we are dropping 3, and it becomes 3 times 2, which is 6, and then you subtract 1 from 3, which becomes 2. Then for this one, you are dropping 5, and it becomes 3 times 5, which is 15. Then x to the power 5 minus 1, which is 4. Then for the fourth one, here we have a different term here. This is a constant, right? Note that if you differentiate a constant, it becomes 0. So I have differentiated 2x squared here, and it becomes 2x. And I have differentiated 2x, and it becomes 2, because we are saying you are dropping the power. This is power 1, and you are dropping the power, and 2 times 1 is 2. Then x, you are subtracting 1 from the power, then it becomes x to the power 1 minus 1, which is x to the power 0, and which is 1. Then if you differentiate a constant, it becomes 0. Then we don't have any other term